Hey everyone, we just wrapped up a deep dive research report on the state of robotics and physical AI. And honestly, the findings were so fascinating that I had to jump on here and share the biggest takeaways with you directly. So, the core realization is this: the robots are coming. And I don't mean in that very vague Jetsons someday in the future kind of way. I mean soon. We've been talking to founders in the robotic space, the people on the inside, and they all say the same thing. The technology is moving way, way faster than it looks from the outside. So today we're going to pull back the curtain on our research. We'll look at the undeniable signs that a robotics revolution is here, the mind-bending challenges they're solving, and the real bottleneck that we need to overcome. So stick around because by the end of this, you see the world a little bit differently. So, okay, why are we convinced that this is happening now? Our report identified four key signals. Sign number one, the humanoids are here. For years, humanoid robots were basically science fair projects. They were cool to look at, but mostly clumsy and confined to a lab. That's over. Companies like Tesla, Figure, Boston Dynamics, and Agility are moving from secret development into active real-world pilots. BMW has Figure's robots working in their factory. Mercedes-Benz is testing out Apptronics robots. Amazon is using Agility's Digit in their warehouses. And so we're talking about maybe like 150 of these advanced humanoids in use right now in the US. That number might sound small, but it's the spark. A successful pilot of 20 robots in one factory quickly turns into an order for 200 to automate the entire production line. So based on the current production signals and contracts, our internal model projects that we could see over 800,000 humanoid robots operating globally by 2030. That's the shift from experiment to commercial scale. Sign number two, the world needs them. Globally, human labor is a $30 trillion market, but we have a problem. In major economies, there just isn't enough people to do all the jobs thanks to lower birth rates, less immigration, and earlier retirements. Labor is getting more expensive and harder to find. This is really a structural trend. Humanoid robots that can step into repetitive or dangerous jobs without needing a whole factory built around them are the perfect solution. Some analysts see the robotics market hitting maybe 450 billion by 2034. But our research suggests that probably feels a little bit too low. When you factor in the new wave of physical AI, we're likely looking at a market closer to $1 trillion. And nowhere is this happening faster than in China. In the last 2 years, China installed more than half of all new industrial robots in the entire world. This year, Beijing launched a state-backed fund to pour up to $138 billion into robotics, AI, and advanced manufacturing. That is a massive, undeniable signal that they plan to dominate the next era of automation. And finally, just follow the money. Even in a shaky market, private investment is flooding in. Figure AI just closed a $675 million round. Physical Intelligence raised more than $470 million. And these aren't speculative bets anymore. Investors see this as an execution stage opportunity. The breakout is no longer a question of if, but rather when. So if the hardware is coming and the money is here, what's the holdup? What's the one thing we're all waiting for? It's something we call the physical Turing test. You've heard of the original Turing test for AI, which is basically, can a machine fool you into thinking it's human? Well, when ChatGPT came up, it basically passed the Turing test. It could write, it could joke, it could explain things in a way that felt human. The physical Turing test is a robotics version of that moment. Imagine you threw a massive house party. It was a disaster. Cups everywhere, stuff knocked over, a total mess. Can a robot come into that chaotic, unstructured room, clean everything up, load the dishwasher, wipe the counters, and reset the furniture so perfectly that you can't tell if a human or machine did the work? We're not there yet. We're not even close. On some of the best robotics benchmarks, like even a perfectly scripted robot in the real world fails almost 80% of the time. And nearly half of those failures comes from just like grasping things. The world is just too unpredictable and messy for these robots to try. So what gets us there? what's going to get us to pass this Turing test? It comes down to one thing, the policy. In robotics, the policy is the brain. It's the AI model that maps what the robot sees to what it does. The problem is training that brain requires data, a lot of data. And our research identified this as the biggest bottleneck in all of robotics. The AI models that power ChatGPT were trained on trillions of examples from the internet. And the biggest robotics datasets today have maybe 1 million examples. So that's 6 orders of magnitude, 1 million times less data. You can't just scrape the internet for physical data. A YouTube video of someone baking a cake doesn't tell a robot how their joints move, the force they use, or how the dough felt. So how do we solve this colossal data gap? Our report looked at a few strategies that are starting to work. The first is simulation. The idea is simple. If a robot has practiced a task in 1 million different stimulated environments, it'll probably be fine in the 1,000,001st real one. In a simulation, a robot can fail 1,000 times without breaking, train faster than real time, and encounter dangerous situations safely. But there's a huge problem called the sim to real gap. The real world is just a lot weirder than the simulation. The way the light reflects off a countertop, the specific friction of a surface. Simulators are getting better, but they can't capture that infinite messiness, which means we absolutely need real world data. The question is, how do we get it at scale? This is where things start to get really clever. One of the most powerful methods is human demonstration. So instead of programming a robot, you show it. A human puts on a VR headset or a motion capture suit and literally performs the task, controlling the robot remotely. Tesla is actually doing that, is hiring a team of people to do this just to train its Optimus robot. Some companies are even gamifying this. They build web-based games or VR experiences where players guide robots through tasks, and every movement creates useful training data. You could have thousands of people around the world teaching robots how to be useful just by playing a game. And this leads to the ultimate vision, a distributed training fleet. Think of it like Waymo's self-driving cars. They have driven billions of miles in simulation, but also millions on real roads. Every car has a sensor, constantly learning from weird, new edge cases and feeding the data back into a central brain. The same thing will happen with robots. Every robot is deployed in a warehouse, a factory, or a home, becomes part of a collective intelligence, making the entire network smarter with every task it performs. So I'll say again, the robots are coming. Our research shows that the real thorny challenges are becoming less about the hardware and a lot more about the intelligence. It's a data problem. But as we see, there's a clear path to solving it. Right now, humanoid robots feel a lot like electric vehicles felt back in 2013. They seem expensive, they are a little limited and kind of niche. But we all know what happened next. The cost fell, the performance improved way faster than anybody imagined, and then the product arrived that captured the world's imagination. So robotics is waiting for that ChatGPT moment, that physical Turing test we were talking about. And once it happens, the final hurdles are not going to be technical, but it's going to be social and economic. Will we accept robots in our homes and workplaces? And can companies build business models that make sense? Those are questions that we'll be tackling more in our research in the coming months. So thanks for watching. This was a quick overview of our recent research report on robotics. Definitely encourage you to go and read it in full. There's a lot more content and insights within that report itself. And if it kind of blew your mind a bit, hit that subscribe button and let me know in the comments, what's the first thing that you want a humanoid to do for you? I'll see you in the next one.